Good camera controls not only improve usability, they also contribute greatly to the immersion of your game. Some basic concepts have proven useful, and today you will learn how to create a camera controller for a strategy game using Godot and C#. In this first part, we cover the most important basics such as rotating, scrolling and zooming, so that you can easily expand the controller for your own game. My name is Julian, and without further ado, let's start into the tutorial. Let's set up an empty scene. There are different solutions to create a strategy camera, but in my opinion, this is the simplest one. We add a base node that acts as a handle for our camera, so that it can also be easily controlled via code. Then attach a camera 3D to it and move it a little along the Z-axis to focus the view to the center of the parent node. Here you can see how easy it is to move the camera using the handle without changing the zoom or rotation of the camera itself. Fine, let's attach a C# file and call it RTS Camera. For the tutorial, I use Visual Studio Code, but feel free to use the editor of your choice. To make it easier for you to follow me, I'll keep the code simple and expand it step by step. First, I export a float variable so we can control the rotation speed in the editor. Then I bind the rotation to the middle mouse button when it's pressed. A good place to determine the direction in which the user wants to rotate is the unhandled input method, because it's only triggered when the mouse is outside the UI. Additionally, we can easily access the mouse position relative to its previous position, which is greater or below 0 when we move the mouse. From the direction, we are able to calculate the rotation. To reduce possible errors, I use a variable to store and apply the rotation. To prevent a glitch, I initiate it with a rotation from the node. If we set a rotation this way, we need to reset the transform basis. But the value cannot be accessed directly, so we need to put it in a separate variable. At first glance, it seems a bit complicated, but it's very handy. Let's see if it works. Looks promising, but the camera turns into the opposite direction and moves even when the mouse does not. So let's fix it. To switch the rotation direction, we negate mouse motion X, and to stop the movement while the mouse stands still, we reset the variable after usage. Now it works as expected. But just rotating horizontally is pretty boring, so we will make a few changes to also be able to move the camera up and down. To keep the calculation simple, we replace some float variables by 2D vectors. I also rename mouse motion to mouse delta to better describe its purpose. We only had to add the relative y-axis and the rotate x method. The rest is already calculated. Then let's test it. It works as expected. Time to implement the zoom. We start again with an exported variable for the speed. Then add variables for the attached camera and its position. You can either assign the camera directly or attach it via an exported variable. Try out what works better for you. In this tutorial, I assume that the first child node is always the camera. I use the position because, as you will see in a moment, this makes it easier to change the Z value for the zoom. In the input method, we listen if the mouse wheel is pressed. In my opinion, it's a bit confusing because the wheel is actually turned, but as you will see, it works. We can determine the direction by wheel up and wheel down. The values passed to the method work like the mouse delta above. It works. Finally, let's add a min and a max zoom. That looks good. The only function missing is moving the base node, or rather, scrolling. For this step, input maps are very useful, but to keep this tutorial simple, I will use direct key bindings. But you don't have to wait long. We will use input maps in the second part of this tutorial. As with the previous features, we're using directions again, this time to calculate movement. I handle them separately, so diagonal movement is also possible. When we move the parent of the camera, we have to pay attention to its local orientation, otherwise we will run into problems after a rotation. For a better understanding, I use variables for the directions, but you can also use the values directly. Let's see if it works. Almost right. But as you can see, after a rotation on the x-axis, the camera moves towards the box and not over it. This is due to the orientation. Except for the rotation around the y-axis, we have to ignore all other rotations. That looks better. The only thing missing is scrolling when the mouse pointer is at the edge of the window. The best thing about it is that we can reuse most of what we have already written. Let's add another export, so we can modify the size of the scroll area. Then, we need to check to determine if the mouse is at the edge of the screen. If we let the method return a direction, we simply can reuse scroll direction. To calculate if the mouse is within the area, we need the mouse position, the viewport size, and the size of the area. The direction is used by the mouse move method, and returning 0 stops movement while the mouse is moved outside the area. Now we just need to find a better place to reset the direction, otherwise edge scrolling will only work while the mouse is moved within the area. Since we only need the reset for keyboard movement, the best place for it is a key up event. That's it for now. There are still many more functions, such as checking whether the mouse is outside the window, movement by dragging, or input maps. But that is more than enough content for a second part. I hope you enjoyed the tutorial and learned something new. Write me a comment if you have any suggestions for improvements. Till then, thanks for watching.